Ever wondered what's actually happening when ChatGPT answers your questions, or how your phone recognizes your face, or how AI can create art from nothing? Today, I'm breaking down 5 fundamental architectures, basically 5 different ways of building AI that power almost everything you interact with. Each one solves problems differently. Each one has its own genius. Let's dive in. This is a transformer. And no, not the robot kind. This is what powers ChatGPT, Google Translate, Claude, pretty much every modern language AI you've ever used. Here's the breakthrough. You know how when you read a sentence like, "The cat sat on the mat because it was tired," you automatically know that it refers to the cat, not the mat. That's what the attention mechanism does. Those spheres you see, each one is a word or token, and each one can pay attention to every other word in the sentence to figure out relationships. Unlike older approaches that processed text word by word, transformers can look at the entire sentence at once. That's why they're so fast and why they understand context so well. This came out in 2017 from Google, and honestly, it changed everything. The entire AI revolution you're seeing right now, it started here. CNNs, Convolutional Neural Networks. This is how your phone recognizes your face in photos. See those layers stacking up. Each layer learns progressively more complex features. First layer, just edges and lines. Middle layers combine those into shapes and textures. Final layers recognize complete objects, faces, cars, cats, whatever. It's like building with Lego. Simple pieces combine into increasingly complex structures. And here's what's amazing. The same basic architecture works whether it's recognizing faces, reading street signs, diagnosing medical scans, or spotting defects in manufacturing. Same fundamental approach. This architecture is from 1998. Designed by Yann LeCun, but it's still the workhorse of computer vision. Some ideas are just timeless. So GANs, Generative Adversarial Network. This is where it gets wild. You've got 2 neural networks fighting each other. One tries to create fake images. The other tries to spot the fakes. They push each other to get better and better. Think of it like an art forger versus an art detective. The forger creates a fake painting. Detective spots its fake. Forger improves technique. Detective has to work harder, back and forth, over and over, until the fakes become indistinguishable from reality. This is how we get those "this person does not exist" images, deep fakes, AI generated art before diffusion models took over. The catch? Training these is notoriously difficult. They're unstable. Sometimes they just break. But when they work, the results are incredible. Ian Goodfellow invented this in 2014, and the creativity of the approach, competition as a learning mechanism, is still influencing AI research today. Now, vision transformers. This one's from 2020, and it kind of broke everyone's brain. For over 20 years, everyone thought you needed those convolutional layers to understand images. That was just the established way vision worked. Then some researchers at Google asked, what if we just treat images like text? Cut the image into patches, apply the same transformer attention mechanism we use for language. No convolutions, no special vision specific architecture, and it worked. Sometimes even better than CNNs. Those patches you see being processed, that's the whole image being understood as a sequence of visual tokens. No special assumptions about visual structure needed. Sometimes the biggest breakthroughs come from questioning the fundamentals. Last one, diffusion models. This is what powers Midjourney, DALL-E, Stable Diffusion, all the state-of-the-art image generation you're seeing now. The way it works is actually backwards. You start with a real image and gradually add noise bit by bit until it's just random static, pure noise. Then you train a neural network to reverse that process, to denoise, to go from noise back to a clear image. Once you've trained it, you start with pure random noise and just run the denoising process. And out comes an image, a completely new image that's never existed before. See those spheres getting progressively noisier? That's the forward diffusion process. The arrows show the AI learning which direction to denoise in. It honestly feels like magic, but it's just mathematics, really, really clever mathematics. This approach has largely replaced GANs for image generation because it's more stable, more controllable, and produces better results. So, 5 architectures that are powering modern AI. Transformers understanding language, CNNs seeing the world in layers, GANs learning through competition, vision transformers rethinking vision entirely, diffusion models creating art from noise. Each one provides a glimpse into how we can turn math into something that looks like intelligence. I'm here to demystify this stuff, peeling back the layers so you can see the engineering reality behind the hype. If you're into that, stick around. And I'm curious, which of these 5 do you think is the true game changer? Let me know below. Thanks for watching.